Hi everyone, welcome back. We continue on this. Lastly, we learned about SimpleBlobDetector class and we check how to initialize it. And in this video, we are gonna focus to the parameters of this class is taking. For example, the parameters I'm talking about, if we go to the class in here, there are some members in here. You can see minimum area, maximum area kind of things. Many parameters in here exist. So actually these are in the previous video we were using the default one. In this video we are going to learn the purposes of these member parameters. Okay, also I already comment out in here to be able to earn time. And if we check again, lastly we just use this image. This image is good because at least we can easily understand the logics of these parameters. But of course in your scenarios it's gonna be some tough images, but if you do not know the reason of these parameters, you cannot also achieve your goals. Okay, we are gonna continue on this one. Actually let me comment out these things. First of all, before initialization of these parameters, maybe this blob detector is getting the default parameters. If you want to learn the default ones, just you need to check because I think in the CPP side of the, because in here not initialized, so I guess it's initialized in the CPP side, which is you need to check also from the source code. You can check, but the simple one, I think in here just console out and just write, let's say params dot just learn minimum threshold. What is the default one? Just write here and see the result. For example, the default minimum threshold is 50. But in here, if you change, of course, it's gonna change after. So 50 becomes 10. So you are assigning accordingly. So all of these parameters has default one, and you can check before changing them what is the default one, because it seems default is not working for you. Just use the manual which you want to use. You can change, you can assign that parameter from here. Okay, we are gonna go one by one, and here the minimum threshold and the maximum threshold. Since the other parameters filterByArea, circularity, convexity, inertia, I assigned all false, so these are not meaningful. It's not gonna consider, so we are gonna continue by one by. This minimum threshold and the maximum threshold, but just because since I'm getting some weird things in here, small things to eliminate them, just temporarily we can learn this filterByArea, what this means. First of all, just learn this at the beginning. Then if we make this true, now it's gonna consider this minimum area and the maximum area. What does it mean? For example, these blobs each has an area, black pixels has a count, so that means the calculation of the area for each blob. For example, we assign this 100 to 20,000, which is big. If I increase this to 2,000, let's say, maybe some is gonna be eliminated. As you can see, it's only these are smaller, I think, comparing to others, because so other blobs area is bigger than 2,000 pixel, we can say. Also, if you decrease this to 1, maybe we are gonna get some weird things again. Yeah, as you can see here, now we are getting more smaller blob. Why the others are ignored? Previously there were big areas, because the other parameters are also affecting. Okay, we can keep it 100 and we can keep this 2000 for now. If you make it false, it will be not considered. Just to keep in mind, it will not calculate according to these parameters. But if you make it true, it's gonna consider. Now with true, we can see all. We can continue with this one. We already checked this. Now the minimum threshold and the maximum threshold. This threshold is about the intensity of the pixels. Intensity, I think you already know. Intensity is the pixel value of each pixel. What I mean, let's see. Okay, this is our image, and if you zoom from here, you can check. For example, in this coordinate, the pixel value, the pixel intensity is 33, 33, and 33. So this kind of RGB values. But of course, this is only one number. It's considering only one channel, which means it's converting to the grayscale this blob, this image, and after that is calculating these values according. For example, as I said, this is around 33, this pixel for each. If you make it, let's say 30, which means ignore the values above 30, about the intensity. So each is about 33, all is ignored. Also, if you make it 35, maybe some is gonna be considered. Still no. Let's make 44. Maybe because we didn't check each pixel, some is bigger than 44 or 55. Okay, 55 it seems meaningful. So now these are considered because the pixel values is above 55 ignored, since all the blob intensities, pixel values are smaller than 55, so it's now able to calculate accordingly. So this is basically filtering the pixel values which you want to detect. For example, let's say in here you have yellow blobs and you want to filter them. This minimum threshold and maximum threshold is gonna make that work easily. Okay, this is also fine. We can pass here, and the next is filterByCircularity. You can easily understand from the naming. This is filtering according to the circularity. 1 means totally circle, and 0.7, let's say close to the circle. Let's see how we are gonna see. Now we see nothing, so 0.7 also very close to the circle, it's meaning. So all is far from a circle. Maybe some is, for example, this half is circle, but let's decrease it to the 5. And some is coming now. So this blob detector saying this is almost a circle. I think it's right. Also, maybe this is not correct, but this is also right, I can say. So now is calculating according to the minimum and the maximum value you are giving. Is calculating which is close to a circle. Yeah, 1 is closer to the circle, and far from 1, which is the minimum circularity value, is meaning this is far from the circle. This is also done. We can make this false for now. FilterByConvexity. This is also important. For example, if I make this true, and let's say to understand what the meaning, maybe we can make it 0.1 for now. Okay, this means what is convexity? Actually, convexity is each shape if has a corner through to the inside. For example, here this is not convex, but all is in here. I think maybe this is very close to a convex shape, which is no corner coming through to the inside to the center. So this is I can say this is a convex, but the others, this is also convex I can call, but some, if there is something, there is a corner through to the inside of, through to the center of the shape, it's canceling being a convex shape. So just keep in mind first of all. And I think this Y1001 is enough. And let's say 9, which is we are telling give me a really convex shapes. Let's see if there is. Okay, it's saying most of them is convex. And let's make it 99 maybe. Now nothing. Let's make it 95. Okay, now some coming. You see, this is, as I said, this is very good convex, I can say. This is also, this is, but you see the clear ones, I think this also should be cancelled. Maybe if I make 98, if only one left. Anyway, because also some issues related to this pixel. For example, here there is a convexity, even we do not notice from far, but in the calculation some the backend is the backend sees that, so it's calculating accordingly. But anyway, at least it's giving me a perfect convex shape successfully. If I make it, let's say 97, maybe if I can get more. Okay, these are better results. These and these also I can call convex. But anyway, at least these are eliminated with this filtering. So this is calculating, this is eliminating, filtering according to the convexity of the shapes. So we also understood this one. Let's make it false again. The last is inertia. Inertia is a mathematical term, and I think most of us is afraid of this meaning, but it's very easy. Inertia is about the, I can say, if an inertia of a shape is 1, it means circle. But if inertia of a shape is 0, it means a true line only. So between line and a circle, for example, ellipse, let's say ellipse, I can say 0.5, but circle is 1 and a line is 0. Just keep in mind like this way and remember from this calculation. Okay, for example, in here, this is close to the line and this is line, this is also line, but some is close to the circle. So how we can do that? Maybe I can make here 1 which is close to the circle shape, and I can make here, let's say, 8. So I want now, also I need to make here true, of course. Now I want my shapes closer to the circle shape. Let's see how I'm gonna get. Nothing I get. Okay, let's make it 6 maybe. Now I get, yeah. Now my shapes around circular, but this circular is not like normal circle we are understanding. So the total shapes is around circular. For example, this is very line. Maybe if we make the opposite, you will understand more clearly. Let's make here 0, 1, and the maximum limitation is 0.3. Okay, you see this is through a line. It's continuous. It's not really circular. It's not, yeah. It's there's pressure in the y-axis. You see for each. So these are meaning, these are obeying the rule of we are giving as threshold. If you make it 0.4, let's see if there is more. Yeah, these are also now included. Yeah, if looks like a line, looks like an ellipse. Yeah, not perfect ellipse or perfect circle we are talking about. We are just talking about the shape, shape space, shape spreading. We are talking about that only in here. So these are looks like line, and these are obeying the inertia rule, inertia thresholds, filters we are giving as input. Okay, is also done. There are, I think, I don't want this video longer, but there is one more thing important which is added newly to the OpenCV library, which is collect contours. So basically this is, you can also understand, for example, it's finding this blob, but also I want this function, this class, this detector to give me the contour of this shape. This is very important because I do not only need, in most of the cases, detecting the blob, I also need its contour values, its pixel values, so I can make my calculations or my decisions accordingly. So in the next video, I'm gonna talk about this collect contours. I'm done for this video. Thanks for watching. See you in the next videos.